Welcome to This Explainer. Today, we are unpacking exactly how to jump from a B to an A star in Section 1.5 of the Cambridge Information Technology 9626 syllabus. Now, if you are sitting these exams, you already know that high-mark questions require explosive power. Think of it like Olympic weightlifting. You cannot just jog your way to the top marks. You need maximum effort in short, highly concentrated bursts of analysis. We are going to focus on the advantages and disadvantages of different data processing methods, but more importantly, we're going entirely under the hood to look at exactly what examiners are searching for when they have their red pens hovering over your papers. We're treating this like an absolute masterclass in exam strategy, breaking down the heavy lifting required to secure every single point.
Okay, let's dive into this by validating the absolute biggest challenge students face with data processing methods. A senior examiner for Cambridge recently asked, literally point blank, why do students find evaluating evidence and drawing conclusions so hard? It is a fantastic question, and honestly, the high-stakes evaluation of evidence is exactly what separates the average answers from the outstanding ones. Let's think about two types of students. We'll call the first one Alex. Alex overloads his answers with raw computer science facts. He memorizes the textbook, dumps it onto the page, but includes absolutely zero analysis. He walks out feeling great, but gets a C. Then there's Sam. Sam completely rushes, misses the command word requirements in the prompt entirely, and loses massive points because he described instead of evaluating. In Information Technology 9626, knowing the facts simply isn't enough anymore. You have to know how to weigh those facts against each other to draw a logical conclusion.
So here is our tactical blueprint for today. First, we'll look at the examiner's perspective. Second, the core analytical principles. Third, the technical methodology. And finally, maximizing method marks. Let's start with Section 1, jumping straight into the examiner's perspective to see what the principal examiner reports actually say about lost marks. When we look at the reports, they reveal three incredibly consistent warnings across the board. Number 1, being vague. Examiners want highly specific technical details, not just general statements about data processing. Number 2, ignoring formats. Students completely forget to check their presentation and layout. And number 3, dropping the context. If the exam question is about a specific corporate payroll scenario and your answer reads like a generic textbook definition of batch processing, you are leaving major points on the table. You absolutely must tie your answer directly to the context provided. Before we continue diving into exactly how to fix this, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, getting back to context. Remember Sam, who we talked about a minute ago? Sam loses points here because when he sees a question about a hospital system, he just writes out standard definitions of real-time processing without ever once mentioning a patient, a doctor, or a medical record. The examiner needs to see that you understand how the technology operates in the real world. Moving right along to Section 2, Core Analytical Principles. This is where we build the theoretical foundation of a top-tier answer. The crucial point we have to understand is this core definition: analytical depth over superficial breadth. This goes back to our weightlifter analogy. You cannot just list a dozen shallow facts about a topic like batch processing versus real-time processing and expect an A star. Merely stating that batch processing is delayed while real-time is instant simply won't cut it. The academic benchmarks for this syllabus demand logical, structured reasoning. You must demonstrate a systematic, evidence-based approach. For example, you need to explain exactly why a corporate payroll system requires batch processing, because it needs to handle massive data volumes off hours without disrupting daily operations, utilizing a master file and a transaction file. Contrast that with an airline booking system, which absolutely demands real-time data processing to instantly update the central database and prevent double booking a single seat. One brilliantly explained, contextualized point like that is worth far more than 5 generic bullet points. Stopping like Alex, overloading the page with random facts. Give the examiner the analytical depth they are actually looking for. To do that, you must hit all the distinct cognitive domains to secure those top-tier marks. The syllabus specifically targets 3 distinct assessment objectives: knowledge, application, and analysis. Think of it as a ladder. You start with the knowledge, knowing the actual definition of a processing method. Then you move to application. How does this method work in the specific scenario you were given in the prompt? Finally, analysis. Why is this method better or worse than the alternative, given the constraints of the business? If you stop at knowledge, your grade stops climbing. To force yourself up this ladder, top students use the Peel framework: point, evidence, explanation, link. You make your point, you back it up with evidence from the case study, you provide the technical explanation of the computer science principles at play, and you link it back to the specific question asked. If you decode the command words correctly and apply the Peel framework, you practically force the examiner to give you maximum marks. Let's move to Section 3, the technical methodology. This is your procedural playbook for actually writing the answers. This sequence brilliantly illustrates the standard operating procedure you must follow for systematic processing in every single exam answer. We are turning those red pen marks into green check marks right here. Look at these 5 steps. First, identify the key elements from the prompt. Second, apply the relevant IT principles. Third, execute your analysis, and, this is absolutely critical, with clear working. Fourth, verify your results to make sure they actually make sense, and fifth, present them properly. If you internalize this specific sequence, you will never stare at a blank page wondering how to start an answer again. Imagine you have 60 seconds to rewrite a flawed answer. By applying these 5 steps, you instantly move from a disorganized panic to a highly structured, surgical approach to extracting marks from the mark scheme. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Now, zooming in on that final step, presentation. Please do not forget the strict conventions for this stage. Practical application in section 1.5 is all about demonstrating professional skills. Using proper headings, correct IT terminology, appropriate formats, and clear annotations is completely non-negotiable. If you've done brilliant analytical work, but you present it as a massive, messy block of text without the right terminology, like saying the computer updates it later instead of the master file is updated via batch processing, the examiner cannot and will not award you full marks. Finally, let's tackle section 4, maximizing method marks through evaluation and critical analysis. I want to run a quick, interactive challenge with you right now. Notice the stark difference between these two approaches. On the left, we have a vague, superficial answer. This is our classic Alex answer. Lacks context, misses format conventions, just a raw data dump. On the right, we have the evaluative, top-scoring answer. This candidate questions assumptions, considers different perspectives, and justifies decisions with evidence using that Peel framework we discussed. If you were to scan a complex data table about network latency in a processing system, the student on the left just lists the numbers. The student on the right extracts the core trend, identifies the flaw in the current setup, and writes a perfect paragraph explaining why it matters to the business. Top candidates justify every single decision they make with hard evidence from the prompt. They don't guess, they prove. When you are evaluating evidence quality, especially for those heavy 8 to 10 mark questions, you must explicitly write out these 4 critical analysis elements. To construct a highly justified recommendation, ask yourself, what are the limitations of the data I've been given? What assumptions am I, or the business in the prompt, making? Are there alternate interpretations of this data processing setup? And finally, how do all these factors actually affect the final conclusion? If I gave you 30 seconds on a timer right now to speed write a paragraph, your goal should be to include at least 1 limitation and 1 alternative interpretation. Writing this out explicitly shows the examiner you are thinking at the highest possible analytical level. You are not just accepting the prompt at face value, you are deconstructing it. Now, if you take away absolutely anything from today's session, let it be this critical alert straight from the marking teams. Method marks can save you. Always, always show you're working. In these IT papers, marks are heavily awarded for the process itself. Even if your final calculation, recommendation, or conclusion is completely wrong because you made a tiny, silly mistake early on, clearly showing your systematic process captures those method marks. Never just write down the final answer. You have to explicitly show the examiner exactly how your brain got there. To pull all of this together, here is your ultimate exam strategy loop. I highly recommend taking a mental snapshot of this system, because these are the rules that guarantee top marks. Phase 1, deconstruct. Decode the command words, identify the given information, and break the problem into logical steps. Phase 2, solve. Systematically process the data, apply the Peel framework, and check if your answer is actually reasonable in the real world. Phase 3, evaluate. Make those justified recommendations based entirely on evidence and a solid time management matrix. If you run every single question through this 3-phase loop, your answers will practically structure themselves, maximizing your mark potential every time. So I'll leave you with this final question to provoke your next study session. How will you apply the deconstruct, solve, and evaluate framework to your very next past paper question? Knowing the theory is only half the battle. The real heavy lifting happens when you put it into practice.
Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here. Keep up the great work, and we will see you in the next one.